in this tutorial, I will show you how to use calculations for different times when you, for instance, have a powering circuit where the power or the current of your coil changes versus time. You can do this for any calculation. In this case, I'm going to show it for the mesh calculation. But then it's first important to make sure that there's something changing versus time. So I add a circuit, a powering circuit, and I choose, for instance, a sine wave because that's nicely changing versus time. I set a different amplitude. Oh, excuse me. Then you can see here, if you hover over the graph, you can see that the amplitude is 200 amps now. I changed the offset a little bit. I don't want to have the zero line at 0 but at 50. I changed the frequency to 50 hertz. Now you see that the time axis has also changed, and I want to have a phase shift of 45 degrees. If I now go to the calculation settings, the quickest thing if you want to do a lot of time steps is you select VTK settings and you store your files, for instance, in the directory meshcalc time. You can use the plus button to create a new directory, select OK, and now we're in our meshcalc time directory. You then specify the range of times you want to save data for and the number of times you want to do this for instance 25. And because you're storing the data to files and you need to make sure that Rat knows, you need to press calc and write and not calculate. If you press calculate, you will see the result for time 0, because that's what we said here only, while if you want to store all your files, you select the time range number of times and then you press calc and write. If you then go to ParaView and you open your data, if you go in your data folder that you created, there's many files, .vtu, but there's one file on top called coil mesh, in this case .pvd. That's the only one you need to load, and once you load it, it's in your pipeline browser. You click apply and then you see your model, and in your properties list you can actually select, for instance, the magnetic flux density. And because we saved this for different times, we can also plot the results for different times. And by clicking different times, you basically ask ParaView to open one of the .vtu files that was written by Rat. There's a different approach that you can take, and that is by creating individual mesh calculations, and you set those, for instance, to different times. So here I call this one mesh 1 second, and I will save this for 1 second. Add another calculation for 2.25 seconds, and here I say 2.25, and so on. I'll do this one more time for demonstration. Oh, made a typo. Typing is very difficult apparently. So now I have 3 mesh calculations. They all need to have a circuit, and then you can calculate for each of these. And then you will also see the results at different times. So here you see at 3.4 seconds it's 1.2 Tesla, 2.25 it's 0.6 something, and here it's also 0.1 something at 1 second. I can show you with the peak value that they are all different. Peak value of this one is 1.33. I chose the timing. Did I not? Right. Yeah, I did. Maybe it's perfectly convenient time step to have almost the same field. Yeah, you see now it's already changed again. So that's how you can visualize the data at different times in the Rat GUI. But if you want to have multiple time steps, I recommend using the VTK settings, changing the time range, selecting a directory, saving 40 files, writing them, and then opening them in ParaView, such that you can actually see the multiple time steps easily in a sort of a browser. And there might be a nice button here. You can rescale the data range over time. That if you have lots of files, this takes lots of time as well. But you can then see that this goes from the maximum to the minimum value, and then the colors are you can more easily compare the colors for different time steps. And you see here it's going through a sine wave. So this is how you go and use ParaView and Rat GUI together to calculate the magnetic field properties of your coil at different times.